You are listening to the Vocal Technologist. Spoken tech for your ears.
So I walked into your place the other day, mate, and I swear I thought I had stumbled into a warehouse logistics center instead of a kitchen. What on earth was going on with the pantry?
Look, it was an experiment in efficiency. I decided to reorganize the shelves based on usage frequency rather than, food groups.
Right.
I figured if I use the olive oil every day, it should be at eye level right next to the coffee beans and the Vegemite.
Yeah, but I saw the flour bag balancing precariously on top of the toaster, and I just thought,
Yes, well, that was a caching error. It turns out frequency of use does not account for structural integrity. I could not find the tea bags without knocking over the pasta. Total chaotic mess.
classic over-optimization. But you know what is funny you mentioned that chaos, because it is exactly what happens when companies try to wrangle their data infrastructure without a proper system.
Oh, absolutely.
It is like a messy pantry.
Yeah.
If you do not have sturdy shelves, the whole thing crashes down on your head.
It really is. And usually right when you are trying to cook up something important.
Spot on. And that is what we are going to unpack on Vocal Technologist. We are looking at how the big guns like Pinterest and Netflix and a few others are tidying up their acts. They are cutting costs, fixing memory leaks, and proving that sometimes the simplest solution, like a basic sturdy shelf, beats the complex AI-driven one.
It really is a case of discipline winning out over hype.
So let us get into it. I want to start with Pinterest. Now, you as a listener have probably been there, right? You're scrolling looking for a recipe for banana bread or a DIY deck project, and it all looks smooth.
Yeah?
But behind the scenes, their data engineers were fighting a massive headache with Apache Spark.
That is right. They were battling these persistent out-of-memory errors, or OOMs, as we call them.
Right.
It is the absolute bane of the existence of any data engineer. Basically, the system runs out of RAM and crashes the job.
And for Pinterest, this was not just annoying. It was costing them big bickies.
Huge money.
Yeah.
And the time spent manually tuning these jobs was ridiculous. So they built something they call auto-memory retries. Now, my first thought, being the simple bloke I am, is if you run out of memory, just give it more memory, right? Throw some more RAM at it. If my laptop is slow, I buy more RAM. Why is that the wrong instinct here?
It is the intuitive answer, but in distributed computing, it is often wrong. What is fascinating about the solution Pinterest came up with is the logic they applied. They realized that a lot of these crashes were not actually a kend because the data set was physically too big for the memory chips.
Okay.
They were caused by CPU contention.
Hang on, explain that. How does the processor fighting itself look like a memory error?
Think about how Java, which Spark runs on, manages memory. It uses garbage collection. It constantly sweeps through memory to delete data you are not using anymore. That sweeping process takes CPU power.
Right.
If you have too many threads trying to process data at once, the CPU gets overwhelmed. It slows down the garbage collection.
I see.
The memory fills up with rubbish faster than the CPU can take it out. So the system crashes and says out of memory, but the root cause was actually that the CPU is too busy to clean up.
That is a crucial distinction. So you are drowning in rubbish because the cleaner is on a break, not because the bin is too small.
Perfect analogy. So their automated system does not just blindly add RAM. The first step it takes is actually to increase the CPU allocation.
That is counterintuitive.
It is, but by giving it more processing power, you let the garbage collector do its job. If that fails, then it launches bigger executors, doubling or tripling or quadrupling the resources.
So it is a smart escalation ladder.
Precisely. And the result was a 96% reduction in those failure rates. It is not about throwing hardware at the problem. It is about automated resilience.
I love that concept,
Yeah.
automated resilience. It feels like we spent the last 5 years building systems that were fast but fragile. Now we are finally building them to be tough.
We are. And speaking of tough, Netflix is pulling off migrations that would make most engineering teams break out in hives.
Oh yeah, I read this. Moving from RDS Postgres to Aurora Postgres. Now, moving a database is usually a scheduled maintenance window on a Sunday night at 2 in the morning kind of situation. But they did this with 400 clusters.
400. And they do it without a massive team manually copying files. They built a self-service workflow.
Self-service is doing a lot of heavy lifting there. How do you let a developer just move a live production database without losing data?
You use the write-ahead log or wall. See, every time you change data in a database, It writes a record of that change to a log file before it actually changes the table.
Okay.
Netflix used Aurora Red replicas. They set up a copy of the database that continuously streams those log files from the old database.
So it is like a live mirror.
Exactly. It ensures near zero data loss because every single transaction is replayed on the new copy in real time. Once the mirror is perfectly in sync or caught up, they just flip the switch.
And the application just starts talking to the new one.
With minimal downtime. It is seamless. But the real insight here is not the technology. Read replicas have been around for a while. The insight is the process. They automated the fear out of it.
That is a great way to put it. Usually you freeze because you're scared of breaking things. If you automate the safety net, you can move faster.
And they're applying that same logic to their AI training. They are doing some wild stuff with AI post-training infrastructure.
This bit went a little over my head. They were talking about sequence packing. It sounds like what I do with my luggage before a flight.
It is actually very similar. Think about training a large language model. You feed it sentences, some are short like hello, and some are long paragraphs. If you feed them one by one into the GPU, the hello takes up the same amount of time slot as the paragraph, leaving the GPU idle for half the cycle.
Right, you are paying for air.
Exactly. Sequence packing is like Tetris. They stitch multiple short documents together into one long sequence, so the GPU is always crunching a full load.
Efficiency again.
And they combine that with document masking. Because if you stitch 3 sentences together, you do not want the AI to think they are one long sentence. You have to mask the boundaries so the model knows where one idea ends and the next begins.
It feels like the vibe here is that these companies, Pinterest and Netflix, are building self-healing or self-driving data stacks. Yeah. They're not fixing things manually anymore.
That is the key takeaway. If you are fixing it by hand, you have already lost. The scale is just too big.
Which brings us nicely to the other side of the coin. Cost. Because, let us be honest, the economy is not exactly letting us burn cash like we used to. I was reading about GreptimeDB, great name by the way, and they are tackling the Internet of Things, or IoT.
GreptimeDB is a really interesting case study in doing more with less. In the IoT world, you generate massive amounts of time series data, sensors ticking every second.
And usually you store that on something fast and expensive, right? Like Amazon EBS volumes.
Traditionally, yes, because you need to write that data very quickly. But EBS is expensive. GreptimeDB manages to use object storage. Think Amazon S3, which is usually considered slow and cheap, but they make it perform like the expensive stuff.
S3 has latency. You cannot just write to it instantly.
They use a tiered approach with something called write-optimized LSM trees.
Okay, hold up. LSM trees. Log-structured merge trees. We need to unpack that. I hear this term thrown around at conferences, but what is it actually doing?
Imagine you are writing a diary. If every time you wanted to write a new entry, you had to open the book, find the specific page for that topic, and write it in alphabetical order, it would take forever.
Right.
An LSM tree is like just writing on a sticky note and slapping it on top of the pile. You write purely sequentially, just appending to the end of the list. That is incredibly fast.
Okay, but eventually you have a pile of messy, sticky notes.
Exactly. So in the background, the system takes those notes, sorts them, and merges them into the main book. That is the merge in log-structured merge tree. GreptimeDB does this using columnar parquet files with compression.
So they get the speed of sequential writing, but the cost savings of storing the book in cheap S3 storage.
Spot on. And the headline number here was a 10 times reduction in storage costs.
Mate, 10 times is a massive number in this economy. That is the difference between a profitable product and a dead one.
It is. And this connects to a broader philosophical shift we are seeing, which I like to call logical first architecture.
Ooh, fancy term. Unpack that for us. Is this just another way of saying data virtualization?
It is an evolution of it. For the last decade, the standard practice was extract data from here, load it over there, transform it, move it to a warehouse, move it to a lake. We were constantly physically moving bytes.
The classic ETL pipeline. Extract, transform, load.
Right. But logical first architecture says stop moving the data, leave it where it is. Use a zero-copy approach. You build unified views or logical layers that query the data in its original location.
Give me a concrete example. I am a marketing manager. I need customer data from Salesforce and usage data from the app.
In the old world, engineers would write a script to copy the Salesforce data and the app data into a new table in a data warehouse. Now you have 3 copies of the data, one in Salesforce, one in the app, and one in the warehouse.
And they immediately go out of sync.
Immediately. In a logical first world, you define a view that connects to Salesforce and the app in real time. When the marketing manager runs a report, The system goes and fetches the data right then and there.
So no duplicates.
No duplicates, no storage bloat, and crucially, no governance nightmares where you have 5 different versions of the truth floating around.
That makes sense.
Yeah.
It feels like the trend for data engineering is really splitting into 2 camps. You have got the elite teams sticking to these solid foundations, and then everyone else just drowning in technical debt.
And drowning in what I call reckless shortcuts. A lot of teams are using AI to write bad code faster, but the elite teams are using AI to enforce discipline.
Speaking of AI, let us talk about the agent layer. This is where things get a bit sci-fi. A go to the travel mob, they are doing something pretty clever with their internal APIs.
They are. They have built an API agent. Basically, it takes their internal APIs, whether REST or GraphQL, and turns them into MCP endpoints without writing any code.
MCP. That is a new acronym for the bingo card.
Model Context Protocol. It is essentially a standard language that allows AI agents to talk to software systems. Before this, if you wanted an AI to book a flight, you had to write custom code to teach it how to use the booking API. MCP standardizes that handshake.
So a GOTUS tool lets an AI agent query multiple internal systems easily. But wait, if an AI queries a database, could it not get back a million rows?
That is the bottleneck. AI context windows, which are basically their short-term memory, are limited and expensive. If you dump a gigabyte JSON file on it, the thing just chokes.
How do they solve that?
They use DuckDB.
The little in-process database.
The very same. They run a tiny, super fast database right inside the agent process. The agent queries the big system, pulls the data into DuckDB, summarizes it locally, like saying, give me just the top 10 most expensive hotels, and then feeds that summary to the AI.
That is slick. So instead of dumping a spreadsheet on the AI and hoping for the best, it summarizes the key points first.
Exactly. It saves money on tokens and makes the AI much more accurate, but this brings up a huge problem.
There's always a problem.
If you have agents running around making decisions like booking hotels or refunding customers, how do you know why they did what they did?
Yeah, the black box problem. Computer says no.
Right. Most systems store the state, like the booking was canceled. But they do not store the decision logic. Why was it canceled? Was it a fraud check? A user request? An inventory error? Did the AI hallucinate a policy?
So we need a way to record the thinking process, a flight recorder for the AI.
We need context graphs. Think of it like a replayable world model. It captures the decision, traces the constraints, the evidence. It is the difference between seeing a car crash and seeing the black box data of what the driver was doing beforehand.
I like that analogy. So if the AI hallucinates or makes a bad call, you can rewind the tape.
Precisely. And that leads to the security nightmare. If you have agents accessing data, your standard policy engines like AWS Cedar do not really cut it.
Why not? Do they not just say user A can see file B?
They do, but that is static. It is a list. AI agents operate in dynamic, real-time relationships. Maybe the agent can only see the file if it is acting on behalf of a manager and the project is active and it is during business hours.
So it is about context and relationships, not just rigid rules.
Exactly. It is called relationship-based access control, or RBC. Google Zanzibar is the gold standard here. You need to verify access based on the live graph of relationships.
It sounds like we are moving from a world of lists to a world of webs or graphs.
That is a great way to put it. The complexity has moved from the code to the relationships between the data.
Now, I want to pivot to something that shocked me. We always assume AI is getting smarter and more complex. We assume the answer to every problem is more layers, more neurons. But there was a benchmark from Flowtorch recently regarding RAG, or Retrieval Augmented Generation.
Ah, yes. This is a classic Emperor has no clothes moment.
So just to clarify, RAG is how you get an AI to chat about your own data. You chop your documents into chunks, and the AI finds the relevant chunk to answer your question.
Right. And for the last few years, everyone has been building incredibly complex semantic chunking algorithms. They use a small AI model to read the text and figure out exactly where one idea ends and the next begins, so they cut the document at the perfect, meaningful spot.
It sounds smart.
It sounds very smart. And Flowtorch tested this against recursive character splitting.
Yes.
Basically counting to 512 characters and chopping it, then backing up 50 characters and chopping again. The absolute simplest method possible.
Like cutting a cake with a chainsaw versus a laser scalpel.
Yeah.
And the winner was.
The chainsaw. The simple splitting actually outperformed the complex AI-driven methods in retrieval accuracy.
Get out. Why?
Because language is messy. When you try to use AI to find semantic boundaries, the AI often overthinks it or gets confused by formatting. The simple overlap method, just cutting it into blocks with a little bit of repeated text, ensures you never accidentally cut a sentence in half in a way that loses context.
And I reckon it is cheaper, too.
Massively. The complex method requires running a model over every single document. The simple method is just string manipulation. It had 3 to 5 times lower infrastructure costs.
That is hilarious. We are over-engineering things because we cannot because we should.
It is the pantry shelf again. Sometimes a wooden plank is better than a robotic arm.
Speaking of seeing things clearly, or maybe not clearly, Google is doing something interesting with maps.
Yeah, map trace. This is a quick one, but it points to the future. They are teaching AI to read maps with pixel-level accuracy. They are generating millions of annotated map images to train these models. It is a reminder that while text is great, spatial understanding is the next frontier for these models.
It is not just reading turn left, it is looking at the intersection and understanding the geometry.
Exactly.
All right, let us look at the shiny new toys before we wrap this up. I love a good tool. What do we got in the toy box?
First up is SQL. This is for the back-end engineers listening. It is a lightweight proxy. You sit it between your app and your database, whether Postgres or MySQL, and it gives you a terminal UI.
Like a retro hacker screen.
Exactly. You can watch your queries executing in real time. You see the bottlenecks, the slow joins right there as they happen without changing a single line of your code. Usually to get that visibility, you have to install heavy monitoring agents. This is just a tap.
That is handy. What else?
Then there is Shaper. This is for the developers who hate dragging and dropping widgets in Tableau or Power BI. It is a self-hosted BI tool built entirely in SQL powered by DuckDB.
So you build your charts with code.
You build everything with SQL. It is Git-based and version-controlled. It treats dashboards like software, not like an art project.
That is a dream. No more final dashboard version 2 edited files floating around.
Exactly. And finally, Polyglot. This is a Rust-based SQL transpiler. It runs in the browser via WebAssembly. It can translate SQL across 33 different dialects.
So if I write a query for Postgres, it can rewrite it for Snowflake.
Or BigQuery or MySQL or SQLite. It handles the formatting, the validation, everything. It is incredibly fast because it is Rust-based and runs on WebAssembly.
Brilliant. No more Googling how to do date math in Oracle.
And God forbid.
All right, let us wrap this up. We've covered a fair bit of ground. Pinterest fixing memory leaks by managing CPU Netflix, automating the fear out of database moves, and the shock realization that simple R-dash pipelines are better. What is the verdict?
The theme is discipline. The move fast and break things era is over. Now it is move fast and build things that do not break. Whether it is using logical first architecture or automated retries, the winners are the ones focusing on resilience and simplicity.
And cost. Do not forget the 10 times savings.
Always the cost.
So what is the final provocative thought you want to leave our listeners with to mull over?
I want to leave you with the concept of data lineage. In an AI world, it is not just a nice-to-have map of your systems, it is the only way to trust your analytics. If you have agents reading data, summarizing it, and acting on it, you need a chain of custody.
Because if the bot hallucinates, you need to know where it got the bad info.
Exactly. If you do not know exactly where a piece of data came from and how it was transformed, you cannot trust what the bot is telling you. Lineage is the difference between a guess and a fact.
If you do not know the origin, it is just a rumor.
Spot on.
Well said. All right, that is us for this one. Go reorganize your pantry structurally, not just aesthetically, and we will catch you in the next one.
See ya.
Spoken Tech for your ears.